I recently did a Valentine's Day themed render challenge with Jorge, and I figured we would take a look at how I went about making the animation that I did for this render challenge. So as always, this project file will be available on Patreon. If you'd like to grab it, you can do so on there. But like I said, this is from a render challenge that I did with Jorge. He made a really awesome animation for this challenge as well. So definitely go and check out his channel. He also makes Houdini tutorials and has a bunch of really cool and really unique tips on his channel. He does a lot of stuff with motion graphics. So if you want to learn more about that, definitely go and check out his channel. So like I said, he has some really awesome tips on there. So I'm going to, like I said, make this the original project file available on Patreon. And in that file, if you look at it, I have the original heart shape as a file that I imported. But I'm going to show how we can actually make that inside of Cops because it turns out it is super easy. And I found that out later on. So let's drop down a CopNet here and let's drop down an SDF setup, which is just a node from the HouMats Utilities release that I have available on Gumroad and Patreon. It just drops down this SDF shape in SDF mono, and we're going to drop down this shape, and we're going to change this shape class from basic to compound so we can get this archway shape. Now I'm just going to change this width to 0.335 and the height to 0.759. These are just some values that I found that work for this. And the reason that we do that is because we don't want this shape to take up the whole square, the whole grid here. Because I want to be able to rotate this by 45 degrees, and we basically have half of our heart shape right now. So I'm going to move this over so it's a little bit more centered, and then I'm going to take a transform, and I'm going to just invert this -1 in the X. And then I'm going to drop down a maximum, wire in both of these to our maximum. And you can see that we have our heart shape already. So let's drop down a transform again, and I'm just going to center this. Not that this matters too much, but just for my own sake. I'm going to center that and drop down a null, wire this in, and I'm going to call this out heart. And I'm going to select this node, and I'm going to go ahead and just copy that, because we can jump out, drop down a SOP create, dive inside and drop down a trace node. We can come into the trace node, set this to cop and paste in that path that we just created. And we have our heart shape here. So I'm just going to say, let this lay flat on the ground plane here. So we'll do 90 and then rotate it around to 180 degrees. And now we have this nice little heart shape sitting on the origin. So let's create an emitter from this for our PopNet. I'm going to drop down a scatter, and I'm going to set the force total count to something low like 3, just to give us a few points to actually emit from. We're going to use these points as our emitter shape. So I'm going to drop the global seed to something different. Maybe this, let's do something a little bit more interesting. Maybe this 18 will work. You can set this to whatever we want. We can always come back and change this later as well. But I'm going to make 3 emitters from this, so they're going to be on different planes. Let's drop down a copy and transform, and let's set this to be a total of 3. I'm going to move them up just a little bit as well, so 0.05, so that we have them on different planes to work with. And that'll be important for later on when we actually go to adding some different noises and things to this. Now I'm going to play around with this rotation as well to give us something interesting for our emitter, and something like that should give us an interesting shape to start off with. Now let's drop down a PopNet. Let's dive inside, and we're going to come up here and set this pop source to not be from the surfaces, but from all points. And that's going to allow us to come to our birth rate here and not emit every frame, but we're going to emit from the first frame. So we'll do $FF = 1. And that's just going to, like I said, only emit from the first frame. Can't tell because we need to add some velocity to this. So we'll set our initial velocity to, instead of use inherited velocity, we're going to do set initial. Now I want to add some variance to this, so we'll do something small like 0.2, and then we'll do 0 for the Y, because I don't want them to actually move around in the Y values. I want them to stay on the same plane that they are. So let's set this last value to 0.2 as well. And if I press play now, you can see that we have these particles that are just kind of floating around, moving around, and that's exactly what we're looking for. Now I want to take these particles and I want them to replicate every so often or split into multiple particles every few frames. So the way we can do that is with a pop replicate node. And let's go back to frame 1 because we're going to need to anyways. And we're just going to wire this into the merge node here. So I don't want to leave this constant activation on because every frame it's going to replicate these particles. You can already see it happening here. So let's turn that off. Let's set this impulse activation. We're going to have this happen every few frames. So in this case, I want to use every 5 frames. So we'll use a $FF and then the modulo function followed by a 5 equals to 1. And if I just click on that impulse activation, you can see on frame 1, it is set to 1. On frame 2, it's set to 0. If I go to frame 6, because that is the 5th frame after frame 1, it's going to switch back to 1 and we'll get some replication happening there. Now we're not saying anything happened because we actually need to set this impulse count. This determines how many particles to split into. So if I set this to 1, each particle is only going to create 1 particle. And if I set this to 2, it's going to create multiple particles. Now you can see that it's kind of creating them in random places, which we don't want. And the reason that it's doing that is because of this shape tab right here. It's set to spheres, so it's going to spawn them within this sphere radius. Now I don't want that. I want them to just emit from the points in the same place that they're in, and we can do that with just this point. Now I'm also going to come to this attributes, and instead of use inherited velocity, I'm going to add to inherited velocity. And again, I'm going to set some randomness of 0.2, 0, and 0.2 in here so that we get some random velocities. So if I press play, you can see that we're going to start to get a bunch of points, and eventually it's going to become too much. So we don't want them to continue to replicate themselves for too long because it's just going to create an absolute ton of points. So the way that we go about doing that is with a pop group. Let's go back to frame 1 again, and let's give this a name. So we'll call this replicate. And I'm going to check this enable so that we have this expression. And you see that says in group equals 1. That just means that it's adding them to the group. So let's set a condition for this. So we'll do if, and then we'll do at frame with a capital F is less than, let's say 55. And then we will add them to the group if it is less than 55. So now if I press play, actually before I press play, if I take this group replicate and I come to our pop replicate and come into this group and we set this to replicate, you can see if I press play now, we're going to replicate up to a certain frame and then it's going to stop replicating there. So it's going to stop creating new points, which is exactly what we want. Now, we have our 3 different planes of emission here, but we have a couple of things that we need to address. First of all, we want the particles to fill up a heart shape. And then we also want to add some actual noise to their movement. We want them to have some nice movement going on. So let's tackle the heart shape first, because it's pretty simple. We're going to drop down a poly extrude here. We'll wire in our trace node. And I'm going to set this to be a distance of like 0.1. I'm also going to output the back here. So we can take this poly extrude now and we can take a transform. We can wire in that into the transform, and we can also take a Boolean, and we're going to create the collider for our particles here. So I'm going to take this, I'm going to take our transform, I'm going to scale this down by like 0.9, and then I'm going to also move this up just a little bit. So something like 0.02 seems to have worked. And we have this nice little heart cutout shape that we've got going on here. So it gives us basically our collider. We just need to turn that into a volume. So we'll do VDB from polygons on the Boolean shape, not the transform. And we need to make sure that this is set to 0.01. Should give us something. We need to, before we do this, if I take a look back at our PopNet here, and let's move back somewhat. We have our initial points here, and if we look at our heart shape, they're already outside of our collider. So we need to increase the size of this. So let's take a transform here. And actually a couple of things, because this is currently sitting on the ground plane as well as our particles on the bottommost layer of our simulation. So let's take a match size first. And if I look at that, that's just going to center or justify our emitter here, or not our emitter, our collider here. And we can take a transform now. And I'm going to just scale this up quite a bit so that we get a nice heart shape here. Something like that should be good. And you can see that all of our particles are contained within the bounds of this object now. If I look at our VDB from polygons and our PopNet, you can see that they're all inside of this collider that we have created. Now I'm just going to take this and I'm going to drop down an SDF smooth just to smooth this shape out just a little bit. And that should give us something nice to work with. Let's drop down a null after this, and let's call this out collider. And I'm just going to copy that actually as well. I'm going to come into our PopNet here. Let's dive inside, and we need to enable our collisions. So for that, we need a static object. Let's come in here and let's paste in that SOP path that we just created. Let's also drop down and merge, and we can wire in our static object into that merge. And you can see that we now have this being brought into our simulation. If I press play, we should be getting some collisions, but we're not. And the reason for that is we just need to come into our collision tab here, set this from right intersect, or sorry, not right intersect, but use volume collisions. And then we need to take our uniform divisions and just up those a little bit to 50. And we should have some nice collisions going on now. So we've solved the issue of our particles filling up our heart shape. Now we need to go in and actually add some nice movement to these particles. So the way that we're going to do that is we're going to come back out of here and we're going to create some velocity fields. Now I've done a couple of videos on how to create velocity fields and visualize them and, manipulate them. So definitely check out those videos if you're interested in that. But we're just going to run through quickly how we can do this. So let's drop down a VDB node. We're going to name this vel for velocity. It does need to be a fog volume, and then we'll set this to a vector float. And then we'll set this to displacement, velocity, and acceleration. And then we're going to drop down a VDB activate. And I'm going to take our Boolean and wire that into the second input here. And for our VDB activate, let's set this to a reference. And let's not look at our particles here. If we look at our fog volume, it's a little bit hard to see here. Actually, we need to take not our Boolean, sorry, but our transform, because we want to ensure that we have our particles, or our velocity field is captured within the entirety of our particles, or sorry, I said that backwards. Our particles are entirely encapsulated within our velocity field so that they don't hit the edges. So that's just going to make a reference of the bounding box for this heart shape, and we can start to manipulate the velocity fields here. So we'll do a volume VOP, and then to actually visualize what's going to happen with our velocity fields, we can just simply drop down a labs vector field export and check this visualize. Now we can see our velocity field here. So if I jump into this volume VOP, we can just disconnect this and we can drop down a bind export. And we're going to call this vel, and let's make sure it is a 3 floats vector. So in here, we can now add something like a curl noise, wire in our position, and then wire that noise into our velocity field. And you can see that we have something going on. I'm going to change this to an analytic simplex noise, and I'm going to just increase the frequency a little bit here just to give it a little bit more detail in there. You can see what this gives us, but we have this really, really noisy thing going on that's going to move our particles in all three directions. And I don't want that to happen. I want them to only be moved along the X and the Z planes. I don't want them to move up in the Y at all. So we need to take a vector to float, wire that in, and then we're also going to take a float to vector, wire that in, and let's just wire in our Z as well. I'm also going to just wire in a constant here, just make sure this is set to 0 and wire that into our Y component there. Now you can see that we've flattened out our velocity field and we have this really nice noise that's going on here. Now I do want to take our offset here. I'm going to middle click and promote that parameter so that we can edit that outside of our volume bop. And I don't want this noise to stay, stagnant. As I move through here, you see that it's not evolving at all. So I'm going to take our offset here. I'm going to type in $FF divided by 100, and that's just going to give us some movement to this velocity field. I'm going to copy that parameter and just paste relative references in for the the Y and the Z components of that as well. The Y doesn't really matter, but whatever. And then you can see that this is going to, evolve over time as I move throughout. Now I have 3 different emitters. If we come back to our copy here, we have 3 different points on 3 different planes that are acting as our emitters. So we do want to create 3 different velocity fields so that we can also just change the offset here in order to get a different looking noise. So I'm going to take our volume VOP here, and I'm just going to do $FF plus, and then just some random number like 50. And then our other one, we're going to just add a different number to it, like 98, sure. And now we have our 3 different velocity fields. And now you can play around with the different settings on these all you want and get some different looks. That's completely up to you. You can add in different noises as well, but I'm just using the curl noise here. And we're going to drop down some nulls now, and we'll call this VF1 for vector field 1, and then we'll make 2 copies of that just to give us our different outputs here. So now we need to add that to our actual particles. So let's come into the PopNet here. Let's dive inside, and we need to do a couple of things first. We need to group these points, and then we need to actually add in that velocity or that VDB advection, or not VDB advection, but our pop advection. So let's drop down a pop group, and we're going to wire this in after the pop replicate here. And let's just call this one bottom. And we're going to set in the bounding regions, and we want to increase the size just so that it encapsulates the whole heart. So we need to go a little bit bigger than that. So 3 by 3 should work. Now, again, we only want this to be including each individual plane. So we will set this to like 0.05. And now we should only have the particles on the bottom. If I come into our geometry here and I play through a little bit, I come to our group here, you can see that we have some that are being grouped and some that are not being grouped. So we have our bottom that's being grouped into those. Let's make a copy of this. We'll call this middle. And then I want to just keep that all the same, but move it up just a little bit, 0.05. And then let's make another one. And let's set this to be 0.1. And we'll call this one top. So we have all 3 groups created. So we need to just take these now. Let's move them up, and we'll do our pop advect by volumes, and we'll do 1 for each. Now you could combine all of your velocity fields if you wanted to. I was doing this really quickly, and it's just super easy to just make 3 different pop advections here and velocity fields. So let's take our stop here and let's set this to VF1 and let's enable our group and we're going to set this to bottom. And I want to update the velocity and we can set the velocity blend down super low, something maybe like that. And then I'm just going to make 2 copies of this. First one, I'm going to set this one to be not the bottom group, but the middle. And we want to set this to our velocity field 2. And then the last one, we want this to be the top group. And let's set this to be velocity field 3. So now if I jump back to the start here, we should have 3 different velocity fields affecting the 3 different sets of points. And if I press play here, real quick, the slow playback is actually because this Boolean is trying to be calculated every frame. If you drop down a time shift node, we can drop this in and we can just delete this relative or this channel right there. If I press play now, you can see that it's actually going to calculate a lot faster. So just drop in that time shift and you should be all set. You don't want to calculate that Boolean every frame. That's what was taking so long with the animation. So you should be all set once to drop down that time shift and you can play back your animation a lot faster. And it's usually not this slow. So probably just due to me recording. So we'll give it just a second here to play. We should have some much better movement going on here with our velocity fields. And we could go in here and play around with the velocity fields if you want. And you can get some different looks to them as well. But we should have the particles start to stop to emit here. And they're going to start to be really affected by those velocity fields, and we should get some pretty nice looking results from the movements here. So we still have that collision that's going to happen with our heart collider there, and here you should start to see some of those velocity fields taking place and starting to really affect our simulation here. So just give it a second to play through, and you can see we get these nice movements that are happening here. You can see we get some swirls that are happening, and we can really have some nice movement of our particles. And the 3 different layers really start to add to the different movements of the particles, and it makes it look like it's almost a fluid-like behavior going on when it's actually just your particles. And again, you can play around with the amount of replication that's happening as well, how long that takes place and everything like that in order to get some different looks. But that is the overall idea of the effect. I can go ahead and jump back and we can play this a little bit faster now. You can see that we get some nice movements of our particles. You start to get those really nice swirls and stuff going on with the particles. So it is a little bit of trial and error with some of the stuff. And again, usually this plays back a little bit faster. So not 100% sure why it's being so slow, probably because I'm recording and stuff. But this is the idea of what's going on with this simulation that I did, or this animation that I did for the Valentine's Day render challenge. Again, make sure that you check out Jorge's channel and take a look at his animation. He made a really nice animation for this, and then as well as the video for it, because I talk about some different things in that video and I'd like to get your guys' feedback, and I don't want to go over that here in this video, but definitely check those out. You can see that we have this nice movement now that it's all cached out. But anyways, hopefully this has helped you out. Lots of different things going on in this setup. So definitely check out the project file. I have like all the rendering settings and everything in there. You can really dive in and see how I did every little detail of this animation. But anyways, thank you guys for watching and have a good day.